Right now, somewhere in a forgotten railroad shed, there is a battery still holding a charge after sitting untouched for 60 years. Nobody maintained it, nobody trickle-charged it. Somebody bolted it to a steel rack during the Great Depression, walked away, and the world moved on. And it is still alive. Meanwhile, the lithium pack in your expensive solar setup is quietly dying right now while you read this. It is losing capacity whether you use it or not. Leave it on a shelf at the wrong charge level for one bad winter, and it will swell, vent, and possibly cook your garage. You spend thousands on a battery that is afraid of cold, afraid of heat, afraid of being too full, afraid of being too empty, and absolutely terrified of time itself. So let me introduce you to the battery that is afraid of nothing. The nickel-ion cell. The Edison battery. The one chemistry that looked at 100 years of abuse and shrugged. This is the battery they buried. Not buried in the ground, buried in history, on purpose, because it was too good to make anyone rich. Let me back up. In 1901, Thomas Edison was watching the lead-acid battery fail over and over in early electric cars. Lead acid was fragile, sulfated, died if you drained it too far, died if you left it sitting. Edison wanted something a working man could not kill. He spent years and a fortune testing thousands of material combinations, and he landed on a beautifully stubborn idea. Positive plates of nickel oxide hydroxide, negative plates of iron, soaked in a bath of potassium hydroxide, an alkaline electrolyte instead of acid. He sold it as the battery that would outlive the machine it powered. And he was right. Edison cells went into mine locomotives, railroad signal systems, lighthouse backups, forklifts, and standby power for the kind of infrastructure nobody is allowed to let fail. Some of those installations ran for 50, 70, even 90 years on the original cells. People have pulled 100-year-old Edison batteries out of basements, scrubbed the terminals, dumped fresh electrolyte in, and watched them take a charge like nothing happened. Try that with a lithium pack. Try that with anything you can buy at the store today. Now here is the part that matters when the trucks stop running. Let me tell you the science of why this thing refuses to die, because the why is the whole point. In a normal lead-acid battery, the chemistry permanently consumes the plates. Every deep discharge eats material. Leave it discharged, and lead sulfate crystals harden onto the plates. Sulfation, and that capacity is gone forever. The battery is slowly destroying itself just by existing. The nickel-ion cell does not work like that. When it charges and discharges, the iron and nickel swap oxygen and hydroxide ions back and forth through the potassium hydroxide electrolyte. The electrolyte itself is essentially a carrier. It is not being consumed into the plates the way acid is. The active materials are not dissolving and redepositing in a destructive way. The reaction is, in chemical terms, almost obscenely reversible. That is why you can deep discharge it flat, leave it flat, even short it out, and it just does not care. There is no sulfation death. There is no narrow voltage window where it commits suicide. Overcharge it? Fine. When a nickel-ion cell is full and you keep pushing current, the extra energy just splits water into hydrogen and oxygen and bubbles it off. The cell does not overheat into a runaway fire. It gases, you lose some water, and you top it back up. Overcharging is not a catastrophe, it is maintenance. Freeze it, the alkaline electrolyte tolerates cold far better than a lead acid that can crack its own case. Cook it in a hot shed, it shrugs at temperatures that would make lithium vent flames. This is a battery with essentially two failure modes. You let the electrolyte dry out, or you let the electrolyte go bad after decades. Both are fixable with a funnel. There are no rare earth time bombs inside. Iron, nickel, a pot of caustic salt water. That is it. So why are you not running one right now? Why did this miracle get buried? Money? Always money. Nickel-ion cells were expensive to build, they were heavy, and this is the killer flaw for a consumer product. They are inefficient. They self-discharge faster than lead acid. They waste a chunk of every charge as heat and gas, and their voltage sags under heavy load. For an industry that wanted to sell you a new battery every few years, lasts a century, is not a feature. It is a business model disaster. Cheap lead acid won the car. Then lithium won everything else by being light. The battery that never dies got quietly shoved into the museum, exactly because it never dies. But you are not optimizing for quarterly profits. You are optimizing for the day the supply chain coughs and nobody is coming to sell you a replacement. And on that day, ugly, heavy, inefficient, and immortal is the best deal on earth. So how does a prepper actually get one of these? Path 1. Buy it. Nickel-iron cells are still manufactured. There are suppliers selling new NIAEC cells, typically sold individually around 1.2 volts each, that you wire in series to build a 12, 24, or 48 volt bank for an off-grid system. They are not cheap up front, but amortized over 50 years against 3 or 4 lithium replacements. The math flips hard in your favor. This is a buy it once, hand it to your grandkids purchase. Path 2. Salvage it. Old Edison cells, forklift knifey packs, and industrial standby cells still surface at industrial auctions, mine and railroad liquidations, and from people clearing out grandpa's shop who have no idea what they are holding. A cell that looks dead is very often just dry or dirty. You clean the terminals, refill with fresh electrolyte, and cycle it back to life, something that is flat out impossible with a sulfated lead acid or a swollen lithium. The $5 part is the electrolyte and the second life, not a brand new bank. The genius of this chemistry is that the expensive part, the plates, can outlast you, so the only recurring cost is a few dollars of potassium hydroxide and distilled water. Now the how-to of keeping one alive, because immortal does not mean zero maintenance. First, the electrolyte. NiFe cells run on a potassium hydroxide solution, sometimes with a little lithium hydroxide added. You buy KOH as a solid, dissolve it in distilled water to the maker's specified concentration, and that solution becomes the bloodstream of your bank. Use distilled water only, never tap water. Minerals will foul the chemistry over time. Second, the safety, and listen closely, because this is where people get hurt. Potassium hydroxide is a strong caustic base. It is lye, it will burn your skin and it will blind you. You wear chemical goggles, not your reading glasses. Goggles and acid-resistant gloves every single time you go near the open cells. You keep water and vinegar nearby to neutralize splashes. You never lean over an open cell with your bare face. Third, ventilation. Charging gas is off hydrogen. Hydrogen plus a spark equals an explosion that ends your prepping career permanently. You put this bank in a ventilated space, no open flames, no smoking, no sparking switches right over the cells. Fourth, watering. Because overcharging deliberately gases off water, the electrolyte level drops over months of use. You check it and top it back up with distilled water. That is the entire maintenance ritual. Check the level, add distilled water, walk away for another season. Now let me be honest with you about the limits, because a man who lies to you about his gear gets you killed. This is not a high-performance battery. It is heavy. You are not putting it in a backpack. It is inefficient. You will need more solar panel to feed it than you would a lithium bank, because it wastes more of what you put in. It self-discharges, so it is not ideal for something you charge once and leave for a year untouched. Its voltage wanders more than lithium under load, so your charge controller and inverter need to tolerate that wider swing. And the upfront cost is real. What you are buying is not convenience. You are buying permanence. You are buying a battery that does not care about the calendar, does not fear the cold, does not catch fire, and can be brought back from the dead with a funnel and a jug of distilled water long after every sealed, sleek, disposable battery in your neighborhood has become a paperweight. Here is the truth. Nobody selling you a Powerwall wants you to sit with. The most advanced battery you can own is not the newest one. It is the one from 1901 that they decided was too durable to keep selling. The future of off-grid power, for the person who actually intends to survive, might just be a 100-year-old idea sitting in a steel can, gassing quietly, refusing to die. They buried it because it lasts forever. That is exactly why you should dig it back up. Stay sharp, stay stocked, and keep your funnel handy. I'll see you on the next one.